Hey everyone, welcome back to the channel Code with AKJ. Today is day 26 of solving LeetCode Scientific Challenge series, and today is the last question from the stack topic, that is decode string. So if you're new to our channel, please make sure to like, share and subscribe to our channel to get latest updates on our LeetCode Scientific questions. So today we are going to solve a LeetCode 394, that is decode a string. It's a medium level problem that's frequently asked in top tech interviews. So again, we'll start with the brute force approach and optimize it to a stack-based solution for better efficiency. So let's quickly dive in. So the question says here, given an encoded string, return its decoded string. Given k encoded string where the encoded string inside the square brackets is being repeated exactly k times. So we are given a number followed by an encoded string which are placed under a bracket, and this particular square bracket string should be repeated exactly k times. So note that k is guaranteed to be a positive integer. You may assume that the input string is always valid. There are no extra white spaces, square brackets are well formed, etc. Furthermore, you may assume that the original data does not contain any digits and that digits are only for those repeated numbers, k. For example, there will not be input like 3a or 24. So the test cases are generated so that the length of the output will never exceed 10 power 5. So we are given an input string with a number followed by a string which is an encoded string which is present between two brackets, and we need to repeat this particular string k times, that is the number of times present before this given encoded string. That is, in this given example, 3a 2bc, the is repeated 3 times and bc should repeat 2 times. So our resultant string would be triple a bc bc. Coming to the second example, we have 3 a2 and c. So here we need to check properly the brackets and the string present inside that particular bracket. So here the brackets are well formed and we need to check properly the particular encoded string should repeat k times. So in this given example, let's try to observe the following output. So here, as you can see, the c should repeat 2 times. So we have two c's here, and the encoded string present here should be repeated 3 times. That is ACC, ACC and ACC. So first we'll try to calculate the value present inside our brackets, that is A to C. First we'll solve this particular thing which is present in our bracket, that is A to C, where C would be decoded 2 times. And finally we'll get a final string, that is ACC, and this ACC should repeat 3 times. So we'll get our resultant string as ACC, ACC and ACC. So that would be our example 2. Coming to the example 3, here again we have a number followed by an encoded string present inside two brackets. So ABC should be repeated 2 times, so we'll get ABC ABC, and CD should be repeated 3 times, so we'll get CD CD CD, and finally EF doesn't have any number to its prefix, so we'll just add this EF into a resulted string, so we'll get this particular output. This was the problem statement, decode string. So let's quickly analyze this question and let's try to come up with an approach. So let's get started with our brute force approach, where we are going to use recursion. So in our recursive approach, we'll iterate through the string. We'll build a decoded result for the first thing, and then we'll recursively call the substring inside this another encoded string. And finally, we'll append it accordingly to our resultant string. So for example here, so we'll iterate over this string, that is S. So we'll first check the character in this string is a digit or not. So if it is a digit, we'll extract that character and we'll convert that into an integer. So for example, this digit may be 2-digit number, that is 31 or 32. For example, we'll extract that number and we'll keep it aside, that is 32. And finally, we'll move on to our next index. So if you find a bracket index, that is current character can be the opening bracket or closing bracket, we'll skip that particular index. And whenever we'll find a character which would be lowercase character, we'll extract that character into the encoded string. This would contain a character, and when we get this particular encoded string, we'll use this num variable and we'll use this string and we'll use a loop, that is while loop. So until or unless this num value becomes 0, we'll append our encoded string into a resultant string. So this would be our approach, our brute force approach, where we are using recursion. after decoding this particular substring, we'll recursively call the next substring to follow the same process. So this would be our brute force approach where we are going to use the recursion. So here the time complexity would be O of n square, as we are going to recursively call the substrings for each, and for each substring we're going to call this while function, and we're going to append this encoded string n number of times. So the time complexity here would be O of n square, and space complexity here would be O of n, as we are using recursive stack. So let's quickly code this approach and let's submit. So here's the code for our brute force approach where we are going to use recursive functions. So initially I have taken index 0, we'll iterate over our string. So I have called the decode recursive function which would return our string answer. So initially our resultant string would be empty. We'll use a while loop until or unless it reaches the end of our string, and until or unless it reaches the closing bracket. Here we are calculating for one particular substring until or unless it reaches a closing bracket. So this would calculate for one particular substring. So here first we'll check if the current character is a digit or not, and if not, we'll directly add our values or characters into a resulted string. For example, in our third example, so here since this particular substring doesn't have any number to its prefix, so we'll directly add these characters into our resulted string EF. So if it is a number, we'll extract that number into our num, and we'll check if that particular number is a 2-digit number or not. So if it is, we'll calculate that number and extract it using while loop into our num variable. And finally, after extracting our number, we'll skip our opening bracket and we'll check for our encoded string which is present after the opening bracket using our recursive function. We'll again call this function and we'll again grab all those characters using this particular string. So after this, we'll get our string value into our decoded part variable, and finally after getting it, we'll again move our index and we'll get our closing bracket. We'll skip it, and finally after getting our first closing bracket, in this case that is 2 ABC, we'll now decode this particular part. That is, ABC should be repeated 2 times here. So we'll again use a while loop where until or unless 2 becomes 0, we'll add this decoded part into a resulted string. So in this way, we'll decode a particular part of this given string, and again we'll call a function to decode this particular part of our string. So in this way, we'll get our resultant string and finally we'll return our resulted string. So let's quickly submit this. As you can see, this solution gives us successful submission, that is 100%. It is getting accepted, but the time complexity here is O of n square because of recursive function, and the space complexity is also O of n because of our recursive stack. So since it is not optimal in terms of time complexity for large number of input strings, so we'll try to optimize our approach and we'll try to use stack based approach here. So let's optimize our approach and use a stack based approach which avoids recursion and runs in O of n time complexity. So we are going to use a stack here. So our optimal approach works in this way. So we'll take a stack and we'll try to push all the characters except the closing character. So let's quickly dry run with this given example. We'll try to insert all the characters until or unless we reach closing bracket. So here we'll start from index 0. So we'll just push this 3 into our stack, and again we'll push a opening bracket into our stack, and we'll push our character A into our stack. And when we reach at this particular index, we found a closing bracket here. So when we find a closing bracket, we'll try to pop all these elements and we'll try to grab all the numbers and the characters into a variable. So after getting a particular closing bracket, we'll take a temp variable, temp string, which would be the stack stop value. That is, we'll pop this character and we'll store it in a temp variable. And again, we'll pop this opening bracket and we'll now extract this number. So the stack value contains now 3. So we'll get a number 3 here. Since this would be in the character format, we'll convert this into the integer using string to I function. Since the stack is empty now, we got our string and we got our number. We'll use a loop to decode our temp variable and we'll store it in our answer variable. So in our answer variable, we'll decode this particular string A 3 times. That is, answer variable contains A. So after calculating this particular substring till we got our first closing bracket, we got our answer variable, and now what we'll do here is we'll again push all these characters into our stack. So now our stack contains A, and we'll move on to our next iteration. So the I value moves to the next index, that is we get 2 and opening bracket B and C. So now again when we reach this particular index, we again found a closing bracket. When we find a closing bracket, we'll again try to grab all those values. So our string temp contains character C and B, and we'll skip our opening bracket and we'll try to grab our number variable. So until or unless we'll find a number variable, we'll stop there. So our number variable would be 2. Again we'll append this value 2 times in our answer string. So in our answer string, the value would be A, and the value would be BC and BC. Since our index would be out of our string, we'll stop our iteration, and in this way we'll get our answer variable and we'll return this answer resulted string. So in our example 1, our answer would be A, BC. So here the time complexity of this approach would be O of n, as we are iterating over our string only once, and the space complexity would be O of n, as well as we are using a stack to store all the characters. So we have optimized our time complexity far more better than our brute force approach. So now let's quickly move on to our code and let's do a dry run on the remaining examples, that is the example 2 and example 3 as well. So here's the code for our optimal approach where we are using stack based approach. Here I've taken the string's length stored in variable n. I've also taken an answer variable which would be initially empty. I've taken a stack which would store the character values inside it. I've iterated over our string variable, and if we find closing bracket, we'll do all these operations, and if not, we'll directly push our values into our stack. So initial values would be a number and a opening brackets and the string characters and the lowercase characters. So initially all the values would be pushed into our stack, and when we reach to an closing bracket, we'll first extract our letters. So since we are using stack, the characters would be pushed in reversed orders. So while extracting, we'll try to grab those characters and push that into our answer in reverse order using this particular line. So this particular while loop extract the letters in proper order. So in this way we have extracted letters, and next would be the opening character in stack. So we'll pop that opening bracket, and now we'll extract the number. Same goes with the number. It would be in reverse order. So we'll try to push that values in a proper order by putting the top character in front of the number variable. So in this way we have extracted the number, we have extracted the character as well. Now we'll convert that string character into our number using stoi function, and since the answer variable contains already a character, we'll use a for loop which would run n minus 1 times, and we'll decode that string and append that particular string n minus 1 time into our answer variable. And since we process that particular part of our string, we'll push all those values into our string and we'll clear our answer variable to empty for next processing of substring. So in this way this for loop works if we encounter a closing bracket, and if it is not a closing bracket, we'll directly push our variables into our stack. And finally, after processing all these values, if we still left with our characters, we'll directly push all those values into our stack and append it to our answer variable. And finally we'll return our answer variable. So let's quickly run this code. It's working, so let's submit. As you can see, this also gives us successful submission. But here the time complexity is far more better than our brute force approach, where the time complexity was O of n square, and in this case the time complexity is O of n. So it is also feasible for the larger inputs, that is more than 10 power 5 length of string. So let's quickly dry run these two examples, example 2 and example 3 as well. So let's dry run the two examples remaining. So this is the example 2, the string 3A2C. So again we'll take a stack, we'll push all those characters except the closing character. So here the character will be 3 opening bracket A, 2 opening bracket, and C. So this would be the characters pushed until or unless we encounter a closing bracket which would be at this particular index. So once we find this closing bracket, until or unless we reach opening bracket, we'll try to pop all those values and take all those. The encoded string would be the top most characters, that is C. So the temp variable stores the value C. We'll pop the opening bracket as well, and now we'll take this number variables, that is num value 2. We'll convert this particular character into integer using our function stoi, that is string to integer function. So now since we got our encoded string and a number as well, our answer variable contains CC. So now we'll push this answer variable into our stack again, and we'll clear our answer variable to empty. So now our stack contains 3 opening bracket A and CC. So again we'll move to the next index. We again found our closing bracket, so we'll again grab our encoded string as well as the number. So the temp, that is the encoded string, would be ACC, and the number would be 3, as we are popping all these values from the stack. So again we found a temp variable and a number, so we'll use a while loop until unless the n becomes 0. Our answer variable becomes ACC, ACC, ACC. This would be a resultant string for our example 2, that is ACC, ACC and ACC. So let's quickly dry run our final string, that is final example, example 3, that is 2ABC, 3CD, EF. So again we'll take a stack. We'll push all those values until or unless we reach a closing bracket, that is 2 opening bracket ABC. And when we reach this particular index, we found a closing bracket. So we'll extract our encoded string into our temp, that is ABC. We'll pop the opening bracket as well, and we'll take the number as well, that is 2 here. So we'll use a loop and we'll store the answer into our answer variable, that is ABC, ABC. So now the next step would be to push all this answer variable into our stack again, that is ABC, ABC, and we'll clear our answer variable for further processing. Now while moving to the next index, since it is a number, it would enter into a stack, that is the stack contains 3 opening bracket C and D. Again when we reach at this particular index, we again found a closing bracket, so again we'll grab our temp variable, that is our encoded string. So our encoded string would be CD, which we'll pop from the stack, and we'll also pop the opening bracket as well, and we'll take our number as well. So here number would be 3. So our answer variable again contains the resulted string where we append this particular temp n times, that is CD, CD and CD. So again our next step here would be to store all these values into our stack, that is ABC, ABC and CD, 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 and we'll clear our answer variable to empty. We'll move on to our next index, that is EF, and we'll store all these values into our stack, that is EF. And finally, since we reach at the end of the string, we'll grab all this character value into our answer string, that is by popping these values. When we pop these values, we'll need to make sure that we'll arrange all these values in a proper way, since these are pushed in a reverse order. So our final resulted string would be ABC, ABC, CD, CD and finally EF. So this would be our resulted string for our example 3. So this was a quick dry run for our 3 examples with our stack based approach, which takes O of n time complexity and O of n space complexity as well. So let's move on to our time complexity and space complexity analysis of both the approaches we have discussed so far. So in our brute force approach, where we have used recursion, the time complexity was O of n square and space complexity was O of n for recursive stack. And in our optimal approach, where we have used stack based approach, the time complexity was reduced to O of n and space complexity was O of n as well. So in this way, using stack based approach, we have optimized our brute force approach time complexity, that is from O of n squared to O of n. So this particular stack based approach is significantly faster and avoids recursive overhead, making it the preferred approach. And that's it for today. We have solved the decode string using both recursion and an optimized stack based approach. So if you found this video helpful, like, share and hit the notification bell so you don't miss out on upcoming videos in the LeetCode 75 challenge. So I'll see you in the next video. Until then, keep coding, keep growing. Thank you.